Hello and welcome to this video tutorial. In this lesson, we're going to be taking a look at the assignment electric force in 2 dimensions. Now, this assignment comes in the form of 4 different questions. The first question is simply looking at a force electric in 2 dimensions. Now, that means we're looking at the force, the distance between any 2 charges in space, and then ultimately applying Coulomb's law to the force. Find the force of interaction between those 2 charges. The second question and the third question, we are going to set our charges in a triangular relationship and find the force on a third charge due to the other 2. In the fourth question, we are going to look at force electric of charges arranged in a rectangular arrangement. Okay, so a box, a square, rectangular, something to that effect. Let's begin with force electric in 2 dimensions. Well, first thing, once you, again, please understand that when you do this, I am providing you an example. When you put in your own name, you're going to be given different data than me. So please use my example here as a template for how to do your own. The first thing you should do is take your charges, locate them, and write them on your screen, like draw them in. So I can see that I'm going over 9 and up 11. Over 9 and up 11 would put my first charge right here. That's Q1, which is negative 545 nanocoulombs. I can see here I'm going over to the left 9 and down 9 boxes. That puts me exactly right here. That's charge 2, and that would be positive 544 nanocoulombs. Okay, now go to your shapes selection in the left toolbar, okay, in Cami, and draw a line between these 2. Okay. Then what we need to do is we need to essentially draw a triangle that goes from here up and over. And we're essentially going to use Pythagorean theorem. Pythagorean theorem would tell you it's the blue line squared plus the gray line squared equals the black line squared. That's ultimately how we're going to find the distance. Just use Pythagorean theorem. So I know that every single line, every single little box, all the major boxes are a half a meter. All the minor ones, the little tiny boxes, are 0.1 meters. So I got to count this up. 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 boxes going up would be 2.0 meters. Okay. If I count going over, 5, 10, 15, 16, 17, whoopsie, 5, 10, 15, 16, 17, 18. So I'm counting 18 boxes along the gray line right here. That would correspond to 1.8 meters. Okay. Oh, sorry. It's in centimeters, not meters. Okay. So I know that this is in centimeters. This is in centimeters. So I can find this distance in centimeters. And then once I find it in centimeters, I can convert it to meters to be able to run the calculation. So here we go. Let's find that distance. The distance, R, is going to be, just use the Pythagorean theorem, it's going to be 2 squared plus 1.8 squared. In my case, enter your own data from your problem. Okay, I'm looking at a distance of about 2.69 centimeters, which would, when you move the decimal twice to the left, would become 0.0269 meters. So there's my distance. Okay. Now, show the calculation of force. Well, step 3, we're just doing using the Coulomb's law equation. So F equals K, Q1, Q2, all over R squared. Okay, and at this point, we can just go ahead and enter in our stuff. So 9 times 10 to the 9, that's K, times charge 1. Now, charge 1 for me is negative 545 nanocoulombs. Don't put the negative in your equation if you have a negative charge. Remember, nano is times 10 to the negative 9 coulombs, okay? So I'm going to be writing 545 times 10 to the negative 9. And charge 2 is 544 nanocoulombs. So 544 times 10 to the negative 9 coulombs. Okay, remember we're putting the distance in meters, not centimeters, so we had to change it. 0.0269 meters squared. Pause the video and plug in your values, and let's find the electric force between your charges that were given. Okay, I'm not sure quite what you got, but when I put this in my equation for my data, I got about 3.69 newtons of force. Now, that's going to be the force and the distance. So the distance in centimeters, okay, was 2.69 centimeters, but the force was about 3.69 newtons. All right, I did it correctly. So please take a moment to make sure you put your data in correctly so you can get the same correct result. Thank you.